The vaccines that we have right now that are currently available do work against the main variants. They don't work as well, but they still work. And that is the key thing to note. So it is a race to get the vaccines out before this virus continues to evolve, because this is a battle against evolution. And we understand evolution sort of in human terms or in mammal terms, so it happens very, very slowly. You and I evolve. It happens over generations. It happens over millions of years because we are made of DNA. DNA is relatively stable. We have long lifespans, relatively speaking, and there aren't that many of us, so evolution takes a long time. Viruses are made of RNA. They mutate more easily, and there are trillions and trillions of viruses out there, and they only live generally a few hours. So with each production, each generation of viruses, there are opportunities to mutate, opportunities for improvements, and that's what we've seen now. We've seen the virus over time, because it has had so much room to replicate. It has had improvements accidentally, and those improvements are propelling themselves forward, creating these new and improved strains. So then you have these amazing scientists who are trying to quickly adjust the technology so that they can compensate as the virus evolves at the speed of viral evolution.
Richard, at some juncture, our attempts to get herd immunity and lots of people vaccinated, we hope, will overtake the fact that the virus is mutating, and it'll be affecting fewer and fewer people, and we'll have developed a certain immunity. Is there a point at which we look like we're in control of this situation?
Well, herd immunity is a funny concept, because with the variants, herd immunity doesn't always apply. Because there was a city in Brazil, Manaus. They had huge percentage of the population that was infected. About 70, some say 80% of the population had the coronavirus. Then a new strain came, and the fact that they had been infected before didn't help them. Their previous infections gave them no protection because they were protected from something that was no longer relevant. The virus had changed. So the most important thing is not necessarily just herd immunity. If you just let this virus go and don't battle it with the vaccines, it will continue to change, and your previous infections might not help you very much. But the key thing is to drive down the numbers, because the rate at which the virus mutates is a factor of how much there is out there. So if you can shrink it, if you can reduce the general amount of virus on the planet, it will still mutate, but there will be less of it. It will be much more controlled, and it will mutate less frequently because there will be fewer options for it to do that. So the way to achieve the herd immunity effect is by getting people vaccinated and reducing the number of virus particles out there.
It's a two-shot vaccine. You get the second shot within a couple of weeks of the first one. After that second shot, or a week or so after that second shot, do people then just take off their masks and go about their business normally?
Well, it is the official recommendation of our Centers for Disease Control that no, you continue wearing a mask, because what we don't know, because of the nature of the way these studies were done and of the very rapid speed with which these were performed, we don't know really whether you're still capable of carrying virus in your body, even though you're not getting severe disease. What we measured in these trials, and in the one coming up for assessment later this week by Moderna, in addition to the Pfizer vaccine, what was measured was a difference in severe illness in the placebo versus vaccine group. So what's been proven is that it's 95% protected against severe disease, but you might still be infected. It's not necessarily protecting you against infection, and it's not necessarily protecting you against being able to infect others. We need more study before we know the answer to that. In the meantime, wear the mask.
What are the differences between Pfizer and Moderna? So, Brian, this is the big issue here, and this is sort of the dust up that we've seen in media over the last 24 hours. Moderna published some early data suggesting that not only does it prevent people from ending up in the ICU, which is the outcome we all desperately want, but it also may prevent transmission of the virus. This notion that the virus can prevent the worst effects from COVID-19, but it can't prevent transmission, that there still might be virus in your nose, and if you sneeze, you'll expose somebody else. Moderna's data suggests that it stops both of those phenomenon. We don't know the same about Pfizer yet. They haven't presented that data. We don't know any of those outcomes for any of the other vaccine candidates. So it's too early to say. So, Brian, to all your viewers out there, please, if you've gotten the vaccine regimen 21 days after the Pfizer vaccine, 28 days after Moderna, it is too soon to let our guard down. You still should mask, distance, avoid unnecessary travel for the time being. It's not going to be forever, just for the next few months as the rest of America gets vaccinated until we reach that 70% mark that we're all hoping for, hopefully by late spring, early summer. And then we can really normalize life here. No one wants to live the current situation for any longer than absolutely necessary, but we want to save lives.